In this video, we're going to complete the KutaSoftware Infinite Pre-Calculus free worksheet Piecewise functions. In numbers 1 through 8, our instructions are to sketch the graph of each function. So let's look at number 1. At number 1, our function of x, for values where x is less than or equal to 2, we have negative 2x minus 1 as our function. For x values greater than 2, we're going to be using negative x plus 4. So let's go ahead and make a t-table in order to plot some points. So here we have x and f of x. Our function equation changes at x equals 2. So that's going to be 1 point that I'm going to want to graph. And because it changes at that point, it's going to be included in this first equation and excluded from that second equation. So I'm going to draw a line to separate my two separate functions. But I'm going to evaluate 2 for each so I get an idea of where it stops and where the jump occurs. Then I'll graph 0 and 1 for my first equation, and I'll graph 3 and 4 for my second equation. Now, plugging in 0 for x, I'll have negative 2 times 0 minus 1, which equals negative 1. So I'll plot 0, negative 1. Then I'll have negative 2 times 1 minus 1, which is negative 2 minus 1, which will be negative 3. So when I'm at 1 in the x, I'm at negative 3 in the y. And then lastly, this value is included. I'm going to plug in 2. So negative 2 times 2 minus 1 is negative 4 minus 1, which is negative 5. So when I'm at 2 in the x, I'm at negative 5 in the y. So I'll go ahead and draw that line, stopping and including that point, 2, negative 5. Now I'm going to plug in 2 for the next part of my function. So I'll have negative 2, since it's negative x, plus 4, and that's going to equal a positive 2. So at 2 in the x, I'm at positive 2 for f of x. However, that point or value is not included, so as opposed to filling in the circle around that point, I'm going to leave an open circle. So 2, 2 will be an open circle because, again, it is not included. This is for values where x is greater than 2. Next, I'll plug in 3, so I'll have the opposite of 3 plus 4, which will be a positive 1. So graphing 3, 1, and then for 4 I'll have the opposite of 4 plus 4, which is equal to 0. So when I'm at 4 in the x, I'm at 0 for f of x. And now I'll draw my line going from that point, and remember that's an open circle because that value is not included, and continuing on towards the right. That is the graph of my piecewise function in number 1. Let's continue on to number 2. For number 2, we have f of x is equal to negative 4 for values where x is less than or equal to negative 2. So I'll go ahead and graph that since it's going to be a horizontal line. So f of x is negative 4 for values less than or equal to negative 2. So up until x is equal to negative 2, all our y values are going to be negative 4. For values negative 2 to positive 2, our equation is equal to x minus 2. So I'll do a quick t-table with x and y values, or x and f of x values, plugging in the endpoints that are not going to be included, which is shown because it's not less than or equal to. So plugging negative 2 in for x and 2 in for x, I'll have negative 2 minus 2, which is a negative 4, and then I'll have 2 minus 2, which is 0. So my first point, which would be an open circle, is at negative 2, negative 4. However, that point is already included in our function, so it will be filled in. And then next, we'll plot 2, 0, and that should be an open circle, and then I'll connect those points. And now we'll pick up when x is greater than or equal to 2. So whatever value this is will be a filled in circle. So doing another f of x table, I'll start by plugging 2 in for x, and then I'll plug 3 in for x, because 2 points form a line, and this is a linear equation. So we'll have negative 2 times 2 plus 4, and for plugging in 3, we'll have negative 2 times 3 plus 4. So negative 2 times 2 plus 4 is negative 4 plus 4, which is 0, and negative 2 times 3 is negative 6 plus 4 is negative 2. So I'll plot those 2 points, one being 2, 0, and look, if you notice, 2, 0 was an open circle because that's where our line x minus 2 ended. However, now we're going to be filling that in because it is indeed included in the function because our third equation, or our third piece of our function, has that value. Then I'll graph 3, negative 2, and connect those points to form a line, and that line will continue on as x approaches infinity. And that's our piecewise function in number 2. In number 3, we have negative 2 to the x for values where x is less than negative 4. So our function is going to change at x is negative 4, and then from negative 4 to 0, we're going to be using another function. So our function will change again at 0, and then from 0 on it will continue. So we will have 2 breaks in our function. If the ends of our intervals do not intersect, we will have jumps in our overall function. So let's make an x, y, t table. Now for this first function, negative 2 to the x for values x is less than negative 4, I'll start by entering in negative 5, and then I'll enter in negative 4. So we'll have negative 2 to the negative 5th, and negative 2 to the negative 4th. But remember, this value, negative 2 to the negative 4th, is not included because it's a less than sign. Negative 2 to the negative 5th is equal to negative 0.03. So graphing that, we'll be at negative 5 and then negative 0.03. So very close to that x-axis, but just below it. And then for negative 4, we'll have negative 2 to the negative 4th, which is negative 0.0, rounding down to 6. And remember, this is going to be an open circle because x equals negative 4 is not included in this part of the function. So finding negative 4, 0.06 is right below that x-axis. It will most likely look like it's touching how close it is. And as we go further into the negatives, such as negative 6, negative 7, negative 8, and so on, we're getting closer and closer to 0. But with the intervals of our graph, it's very hard to see, so we'll just draw a line connecting those 2 points and continuing on right below that x-axis to where it looks like it's almost touching. Now, for the next part of our function, we have the opposite of the absolute value of x. So I'll enter in negative 4, since negative 4 is included. We'll have negative 3, negative 2, negative 1. 0 will also be included, and I need 2 points to form a line. So I'll use negative 4 and 0, since I know the absolute value function will form a line because it will not turn it until after that 0. So it'll be a straight line up until that point. So the opposite of the absolute value of negative 4 is going to be negative 4. And remember, this point is included. So at negative 4 in the x, we're at negative 4 in the y, and we're going to fill that circle in. And then at 0 in the x, the opposite of the absolute value of 0 is simply 0. So when we're at 0 in the x, we'll be at 0 in the y, and that will also get shaded in because the 0 is also included within that interval. And then I'll draw a line to connect. And then lastly, third part of our function, the third piece, we have 4 minus x squared. So we know that this is going to be part of a parabola, so let's enter in 0. But remember, 0 is not included, so it's going to be an unshaded circle. We'll enter in 1, and we'll enter in 2. because this is not a line, it's going to be a parabola, and I want to display the curve more accurately. So the more points we use, the better our graph will look. So entering in 0, we'll have 4 minus 0 squared, which is going to be 4 minus 0, which is 4. So at 0 in the x, we're at positive 4 in the y, but this is going to be an open circle around that point because it is not included. Now we'll enter in x equal to 1. So we'll have 4 minus 1 squared, which is 4 minus 1, which will be equal to 3. So when we're at 1 in the x, we're at 3 in the y. And then next, 2. So I'll have 4 minus 2 squared, which will be 4 minus 4, which will equal 0. So when we're at 2 in the x, we're at 0 in the y. And now I'll draw my curve to fit those points. And that's my piecewise function graphed in number 3. Let's continue on to number 4. In number 4, we have the function g of x. So our y values are going to be equal to negative 6 for values where x is less than negative 2. So when we're at negative 2 in the x, we're at negative 6 in the y, but that's going to be an open circle since that x value is not included in the interval. So where x is negative 2, we're going to have an open circle at negative 6 in the y. And then everything to the left of that is also going to be negative 6. I'm going to want to enter in a few points for the next part of our function because we're going to have a parabola. And in order to get a more accurate curve, we're going to enter in more points. So we're going to have x and g of x. Plugging in a value of negative 2 for x because that is in the interval, we'll have negative 2 plus 1 to the 4th. Negative 2 plus 1 is equal to negative 1, and negative 1 to the 4th equals a positive 1. So when we're at negative 2 in the x, we're at positive 1 in the y, and we're going to fill that in. Now I'll enter in negative 1. Negative 1 plus 1 to the 4th is equal to 0 to the 4th, which equals 0. So when we're at negative 1 in the x, we're at 0 in the y. Next, I'll enter in 0. So if x is 0, 0 plus 1 to the 4th equals 1 to the 4th, which is equivalent to 1. So when we're at 0 in the x, we're at 1 in the y. And I'll go ahead and enter in one more point. Entering in 1 in, we'll have 1 plus 1 to the 4th, which equals 2 to the 4th, and 2 to the 4th is equal to 16. So we're going to be off the graph before we even reach 1. So drawing our parabola, that finishes out our function in number 4. Now let's move on to number 5. For number 5, the first part of our function is for the intervals from negative infinity in the x to positive 4. So having our x, f of x, t-table, I'll graph 0, 2, 3, and 4. Because of my familiarity with functions, I have an idea of what this graph is supposed to look like. So I'm going to do a couple different points to make sure I plot it accurately. So 1 over 0 minus 4 is going to be 1 over 4, and that's going to be a negative 4, so it's going to be negative 1/4. So at 0, we'll be at negative 1/4. For 2, we'll have 1 over 2 minus 4, which is equal to 1 over negative 2, so that's going to be negative 1/2. So at 2, we're at negative 1/2. Then at 3, we'll have 1 over 3 minus 4, which is equal to 1 over 1, and that's a negative 1. So we'll be at negative 1 in the y when we're at 3 in the x. And then finally, for 4, we'll have 1 over 4 minus 4, which equals 1 over 0, which we cannot do. That is undefined. So I know that this is a point of discontinuity, and the way the graph is going, this is going to be an infinite discontinuity. So I'm going to have a vertical asymptote at x equals 4. So I'll go ahead and draw this in. Here's my vertical asymptote to see that I'm not ever going to have x equal to 4. And then I'll draw my graph connecting my 3 plotted points. So as x approaches negative infinity, we're getting closer and closer to 0, and as x approaches 4, we're getting closer and closer to negative infinity. Now we'll look at the second part of this function, which says that for values where x is greater than 4, we're going to be at negative 4 in the y. So I'm going to draw a circle around the point for negative 4, because that's where my next function will pick up directly after that, but not including, and then everything else will be negative 4 to the right. And that is my piecewise function for number 5. In number 6, unless 2 to the negative 3 is equal to 3 over negative 3, the change in our piecewise function is going to occur at the point negative 3, where negative 3 is included in that second piece. So h of x, I'll enter in values for x when x is less than negative 3. So I'll start with negative 3, then go to negative 4 and negative 5. So I can see where that open circle will lie on my graph. So entering in negative 3, I'll have 2 to the negative 3. When I enter in negative 4, I'll have 2 to the negative 4. And then when I enter in negative 5, I'll have 2 to the negative 5th. 2 to the negative 3 equals 0.125. 2 to the negative 4th equals 0.0625. And then 2 to the negative 5th equals 0.0315. So as we go to the left towards negative infinity in the x, we're getting closer to 0. So I'm going to draw an open circle around negative 3, 0.125. And then the rest of my function towards the left is going to be very, very close to that x-axis. Now I'll enter in values for the second part of my function. h of x. And right away, looking at this, I can see that I'm going to have a vertical asymptote where x equals 0 because that's going to be undefined. So I'm going to have a point of discontinuity at x equals 0. So I'll go ahead and draw that vertical line. Now I'll enter in negative 3 and negative 1. I'll have my point of discontinuity, and then I'll enter in 1, 2, and 3. So entering in negative 3 for x, I'll get 3 over negative 3, which is equal to negative 1. So at negative 3 in the x, I'm at negative 1 in the y, and that is a solid or filled in dot or circle because that point is included within that second part of the function. Now, for negative 1, I'll have 3 over negative 1, which equals negative 3. So at negative 1, I'm at negative 3. Now I'll draw my function showing that it's going to get closer and closer to negative infinity because it is an infinite discontinuity. Now I'll enter in 1. 3 over 1 equals 3. 3 over 2 is equal to 1.5. And entering in 3, I'll have 3 over 3, which equals 1. So graphing each of those, 1, 3, 2 and 3 halves, so 2 and 1.5, and then 3 and 1. You can see that we're coming from positive infinity in the y, and we're going to be approaching 0 as x increases. And that's my piecewise function in number 6. For number 7, the first part of my interval is from negative infinity to negative 4, then from negative 4 to positive 2, and then from 2 to positive infinity. So starting with that first part, w of x, I'll enter in negative 6, negative 5, and negative 4. And that negative 4 is included. So entering in negative 6, I'll have the absolute value of negative 6 over 2, which is a positive 6 over 2, which equals 3. Then, for negative 5, I'll have the absolute value of negative 5 over 2, which equals positive 5 over 2, so 5 halves. And then finally, for negative 4, I'll have the absolute value of negative 4 over 2, which will equal positive 2, since the absolute value of negative 4 is positive 4, and 4 divided by 2 equals 2. So graphing each of those, -6, +3, -5, 5 halves, so that's 2 and a half, and then -4, 2, and remember this is filled in because it's a part of the interval. I'm going to draw my line. Now I'm going to look at the next piece of this function that goes from the intervals -4 to 2, and it's the square root of -x. So entering in -4, the square root of the opposite of -4 is the square root of +4, which is a +2. So at -4, I'll be at 2 and the x, and I don't even have to make an open circle because that point's already included from the previous piece of our function. So -4, 2. Next, I'll go to -2, so I'll have the square root of the opposite of -2, which is equal to the square root of +2, which is approximately 1.41. So I'll plot that, -2, 1.41, and then I'll go to 0. So the square root of 0 is equal to 0. And then notice that when I enter in 1 or 2, the square root of a negative number is not real. So I will not be able to plot anything for 1 and 2. So I will stop at 0, 0, because after that, I'm looking at the square root of negative numbers. Now for values where x is greater than or equal to 2, I'll start at +2. We're looking at the piece of the function that's equal to the absolute value of x minus 2. So plugging 2 in, we'll have the absolute value of 2 minus 2, which is equal to the absolute value of 0, which is 0. Then I'll plug in a +3, so we'll have 3 minus 2, which equals the absolute value of 1, which is a +1, and so on. If I enter in 4, I'll have 4 minus 2, which is the absolute value of 2, and this will be a straight line continuing the rest of my function. And remember, this point at 2 is included, so we'll be at 2, 0, then we'll go to 3, 1, 4, 2, and so on as x approaches infinity. Now, moving on to our last part of this section, number 8. For number 8, starting where values of x are less than 1, w of x is going to be the absolute value of x minus 3. So I'll plug in -1, 0, and 1. The absolute value of -1 minus 3 is going to be the absolute value of -4, which is equal to a +4. The absolute value of 0 minus 3 is going to be equal to the absolute value of -3, which is a +3, and the absolute value of 1 minus 3 is going to equal the absolute value of -2, which is a +2. And remember that 1 is not included in the interval, so it's going to be an open circle. So at -1, we're at +4. At 0, we're at +3. At 1, we're at 2, but that's going to be an open circle at that point. I'll draw a line to connect the rest of my points. Now, at x equals 1, we're given that the value of the function is x minus 1 to the 4th. So at x equals 1, we're going to be at 1 minus 1 to the 4th, which 1 minus 1 is 0, and 0 to the 4th is equal to 0. So then we're going to fill in 1, 0. Now picking up after that, for x greater than 1, our function is going to take on the form of the square root of 4x. So I'll enter in 1 to see where that open circle will be, and then I'll enter in a point a little bit further along, 4, so that we can see the shape of that function. So when we're at 1, we're going to have the square root of 4 times 1, which equals the square root of 4, which is a +2. And then for 4, we're at the square root of 4 times 4, which is the square root of 16, which is a +4. So graphing each of those, I know that it's an open circle at 1, 2. So going to 1, 2, we already have an open circle there. So we're going to continue out of that open circle to our next point of 4, 4. And let's go ahead and enter in 8 just to see where that curve lies. So we have the square root of 4 times 8, which equals the square root of 32, and that's going to be approximately 5.66. So then 8, and then 5.6. So now we'll draw our curved line, going from our open circle, continuing off of the graph. And that's the solution to our piecewise function at number 8. 9 and 10 are our critical thinking questions, and for number 9, it says to write a rule for the sine function s of n, where s and n is -1 when n is negative, +1 when n is positive, and 0 otherwise. So our intervals, when n is negative, that's going to be n less than 0. When n is positive, that's going to be n greater than 0, and then otherwise, n will be equal to 0. So we have 3 different intervals or pieces to this function. Now, s of n, it states that when n is negative, so for n less than 0, we're going to be at -1. When n is positive, we're going to be at +1, and otherwise, so when n is not negative and when n is not positive, meaning n is equal to 0, it states that we're going to be at 0. So s of n equals -1 for n less than 0, 0 for n equal to 0, and 1 for n greater than 0. That is our piecewise function in number 9. Now for number 10. 10 says to write a rule for the function below. So we have the interval from -infinity up until -4, but not including 4. Then we have the interval from -4 up to 2, but not including 2, and then from 2 to +infinity. So we do not have a value at -4 or at +2. So our function f of x is going to equal 3 separate pieces. One for when x is less than -4, which is this horizontal line, which y equals 2, or f of x equals 2 at those points. So for f of x, when x values are less than -4, we're at 2. Then, for x values between -4 and 2, so -4 is less than x, which is less than 2, remembering not to use less than or equal to for either of those because -4 and 2 are both not included, we have this line. And luckily enough for us, it's a linear equation, so we'll write it in slope-intercept form. Remember, y equals mx plus b. Our m, our slope, is the rise over run. So going from one point to the next, we're going down 1 and over 1. So that's -1 over 1 for our slope m. So that simplifies to -1. And our y-intercept b is -2. So our equation is y equals -x minus 2. So for values between -4 and 2, where -4 is less than x, which is less than 2, our equation for our function is -x minus 2. And now our last piece of this function is when x is greater than 2. So for x greater than 2, we're going to have another linear equation. So remember, y equals mx plus b. And in this case, our slope m is 1 up and 1 over for rise over run. So m equals 1 over 1, which is a +1. And we're not sure of our y-intercept, but if we were to continue this function to the left so that we could see the y-intercept, that would occur at -6. Using our slope of 1 over 1, we can also go -1, -1, so 1 down, 1 to the left, 1 down, and 1 to the left to get to the point -6. So our b value is -6. So our equation, y equals mx plus b, is going to be y equals 1x, or simply x, plus b, which is plus -6 or -6. So for values when x is greater than 2, we have x minus 6 as our equation. And that is the rule for our function shown in number 10. F of x equals 2 when x is less than -4. F of x equals -x minus 2 when -4 is less than x, which is less than 2. And f of x equals x minus 6 when x is greater than 2. And with that, we wrap up our piecewise functions worksheet. If you haven't already, feel free to leave a comment below, like this video, subscribe to my channel, and share it with your peers.